This is the solution video for question 13 from paper 2 of the 2019 TMUA or CTMUA exam. In this question, we're asked to consider the approximation of the integral of sine squared x between sum a and b using the trapezium rule. We're told when we do this, this gives an overestimate. Following this, we're asked to conclude which of the following must follow from this. The following being 1, if the integral of sine squared x between minus b minus a with respect to it is approximated the same way we approximate this, the result will be an overestimate. And 2, if integral between a and b cos squared x with respect to x is approximated in the same way as we do up here, the result will be an underestimate. And we're given various options for which of these must follow, ranging from none of them, either one of them, or both of them. The first thing to do here is draw a graph so we can get a good idea what's going on. So let's put some axes down and let's try and sketch sine squared x. So it doesn't really matter what it looks like. So it looks something like this, but there's one important feature here which you've probably noticed in that this is an even function, i.e. there is a degree of symmetry around this y-axis. And that's going to be very useful for approximating this one especially, the integral between minus b and minus a. So why is it like this? Well, we know sine x is equal to minus sine of minus x, or in other words, sine's an odd function. But if we square both sides of this, this minus sign has no effect. So we have sine squared x is equal to sine squared of minus x. So sine squared is an even function. So it looks something like this on the right hand side, and correspondingly it will look identical on the left. So now let's introduce an a and b. So we'll put a here, b here, and we've got some trapezium rule approximation. Here I've just done 3 trapeziums. Here, here, and here. So for 1, what are we looking at? Well, we're looking at the integral of this function, sine squared x, between minus b and minus a. And because this is even, this is the approximation of this is going to look something like this. If we take this trapezium rule approximation and flip it like this, so we've reflected it in the y-axis and move it up here, we see that this is the trapezium rule approximation of the function between minus b and minus a. And we knew that this was an overestimate when we did it here, so it would imply that this is an overestimate too, because all the issues of underestimating areas remain with this. All the area calculations are essentially the same because the function is even, and we've just reflected our trapeziums and put them over here. And so we know 1 must hold if we have an overestimate here. Now let's look at 2. So we've got to consider the integral of cos squared x. Now this isn't the same function as we integrate earlier, but it is related because you'll remember sine squared x plus cos squared x is 1. So rearranging that a little bit, cos squared x is equal to 1 minus sine squared x. So we're actually approximating the integral of this between a and b with the same trapeziums. So what do we do now? Well, let's ignore the 1 for now and look at minus sine squared x. So y equals minus sine squared x. If we used the trapeziums we used up here for this, would we get an over, underestimate, or would it vary? So we know our graph looks something like this. Why is that? Well, we've got the minus sign here, so it means we just flip everything in the x-axis, and the trapeziums will be similarly flipped. So we know the trapeziums give an overestimate for the area here, so that means they'll give an underestimate for the integral here because we flipped the sign of everything involved. But we also have to deal with this 1 here. So what effects does y equals adding a constant to this graph do? Well, if we are simply translating the graph up or down, we see we translate both the trapeziums and the graph, and so if we've got an under or overestimate, adding a constant doesn't make any difference. So we know that 2 will be an underestimate, so 2 is true, and a 1 and 2 both being true corresponds to option D in our answers, and so our answer is D.